welcome to the next beautiful topic from electrostatics, which is called electric dipole. So write on the heading on your notebook. Next topic is called electric dipole. So we'll start. A lot of questions are normally asked from the sessions from the previous years. So it's interesting at the same time. We can just play around. Okay, so let's start with the first word, electric. Electric, it's called, electric is related with something called current, or it is also called charges. So now here we have called dipole. Di means, the word meaning of di. Di means two. So pole means, normally we call it as pole, north pole and south pole. So pole means in physics also, it is just opposite. Okay, north and south are opposite, right? The same way here pole means positive and negative. So dipole means, di means two, pole means north and south. The same way here positive and negative. So positive charge and negative charge together is called dipole because there are two charges are there. So write on the definition of dipole. Dipole means two equal, listen here and look into the board. Two equal and opposite charges, which means one is minus q, another one is plus q, separated by a shorter distance. So the distance between them from the center, one is at a distance of L meter away, another is also L meter away. So this distance I am marking as L, this distance I am marking as L. Some reference textbooks are taking D also, small letter d, anything it is fine. So basically it is called distance. So two dissimilar charges, equal magnitude, which means opposite signs are separated by a shorter distance is called dipole. So I am writing the definition of dipole. Two equal means magnitude wise, two equal and opposite charges, two equal and opposite charges separated by a small distance. This word is important, small, a small distance. What is a separation distance will be here? L plus L, total is 2L. Separated by a small distance is called electric dipole. So this is called electric dipole. So hope you understood. It's quite simple representations. We'll go to the next heading. Next one is called dipole moment. Next term, small terms as like you have studied in biology, right? Biology and chemistry and all, you have studied small terms. So especially here also it's called dipole moment. What do you mean by dipole moment? Dipole moment, the first point, dipole moment is a vector quantity. It's not a scalar quantity. Is a vector quantity. So dipole moment is a vector quantity. Dipole moment is representing using a letter called P. Dipole moment P is equal to any one of the charge, whether it is positive or negative, any one of the charge magnitude. Magnitude means Q into distance between them, Q into 2L, and this is called dipole moment. Here I told dipole moment is a vector quantity. So I put an arrow mark. Charge is a scalar quantity. So what will makes this as a vector quantity? L. So this 2L, L is called the distance vector or the displacement vector, and this is called dipole moment. So dipole moment is equal to the product of any one charge into distance between them. Now the question is, what is the direction of dipole moment? It is a vector quantity. So write on the next point, direction of dipole moment. Direction of dipole moment is from negative charge to positive charge. Is from negative charge to positive charge. Negative charge to positive charge means in this diagram representations, I'll put an arrow mark and mark it as P. So this P is called dipole moment, product of any one charge to distance between the charges, and this is called dipole. So two concepts we have learned now. One is called electric dipole and another one is called electric dipole moment. Electric dipole is just a definition, sir, which means it consists of two equal and opposite charges separated by a distance, and another one is called electric dipole moment. Okay. Now we will go into three things we are going to learn with respect to electric dipole. Three different, not a concept, it is something related to, we are going to find out electric field due to a dipole. Within that one we have three subheadings will be there. Okay. So write down the main heading. So we will write a main heading. Under that we have a three subsections will be there. So we will go with the first main heading. So first write down the main heading. Main heading in the sense electric field intensity, electric field, or you can simply write electric field. So electric field due to a dipole, at certain position, So electric field due to a dipole at certain position, So will be here. The first subheading, 3 points we will see one by one. First one, electric field intensity. For example, I am writing E along the axis of a dipole, electric field along the axis of a dipole. So we will represent this as a diagram, then we will go with the derivation stuffs. Okay. So I have an equal and opposite charges. We have minus q and we have plus q, which are separated by a distance of 2L. And exactly from the center, here I am going to find out the electric field intensity, and from the center of this dipole, which is at a distance of x meter away. Okay. So this is a point where we are going to find out the electric field intensity. Before we are going to enter into the derivations or to the formula, to the mathematical expressions, first we want to know few things. Here I am going to find out, listen very carefully. Here I am going to find out the electric field intensity, right? So the electric field intensity here, it's created because of minus q and because of plus q. Minus q is a point charge, plus q is a point charge. Each can create its own electric field at this point. Okay. So the electric field created by minus q, the electric field lines, last sessions we have learned, electric field lines, electric field or force lines are always towards negative charge. So the electric field created by minus q, it's like this. So I am putting E suffix minus q. Electric field created by plus q, it's away from. So plus q, electric field lines are going out, away. So with respect to this point, it is away from the point. And this point is towards minus q, and due to plus q, electric field lines are away from this one. So this is electric field due to plus q. Okay. Now, how we will find the net electric field? Total electric field will be equal to, how we have to find out? Two vectors which are not equal but in opposite direction. How we will find out? Electric field due to plus q minus electric field due to minus q. Why I have taken plus q? E plus q first and E minus q second. Because E plus q is the electric field created by due to q charges at this point. So the general equation of electric field is 1 by 4 pi epsilon 0 q divided by r square. R is the distance from this point to this point. With respect to the distance from minus q to this point, the distance from plus q to this point is shorter. If this distance is shorter, the E value for plus q will be very high, comparable to minus q, because minus q is far away. So large distance means E minus q is less. Here it is a shorter distance, means E plus q will be higher. That's the reasons I have taken E plus q minus E minus q, because this is the largest quantity and this is the smallest quantity. Okay, now the final point is this is the total electric field E plus Q minus E minus Q. We already know this is a higher quantity, this is a lesser quantity. A higher quantity minus lesser quantity, I am subtracting a quantity. So what will be the final? I will get the, suppose you can assume this value is equal to 10, this value is equal to 5. I am subtracting 10 minus 5. What should I will get? The value will be here 5. 5 is a positive sign. Positive sign means this is a higher quantity, this is a lower quantity. So the higher quantity sign is retained. Higher quantity sign is come here means what is the direction of plus E? Along the same direction of E plus Q. Because E plus Q will be higher. A higher quantity minus lower quantity, I will get a quantity. And this quantity also have the same direction of E plus Q. Now we have to solve this one. That's all. Now it's a mathematical process. We will find out. So 1 by 4 pi epsilon 0, I am considering here it as k. Okay, so k into what is the kq divided by what is the distance r square. What is the distance from here to this point? What is the distance? Total is x. Total x minus l distance. So I can say x minus l the whole square, right? This distance is x minus l. Total is x. So l is subtracted means I will get balance of this one. Minus of k into q. Kq divided by electric field due to minus. Here I don't want to put again one more minus. Okay, this is a very high chance you made a mistake will be here. Here I have put a minus. Why the how this minus can? Because I define electric field is towards minus q. So already I put a minus sign will be here for the negative charge. Because of the negative charge, electric field direction is opposite. So you don't want to put one more negative will be here. Okay, because you know it is minus q, so already we have a minus will be there. This minus indicate electric field direction is like this. That indicate it's a negative charge. So you don't want to put again one more minus, never put. Okay, not required to put one more minus. Already this minus indicate it is towards the charge. So already minus is considered. You don't want to put it again. Go further. What's the distance from here to here? What is the total distance? X will be here up to the center. X will be here. So balance distance. So how much will come? X plus L the whole square. We have to subtract this factor. So what is common from this one? KQ 1 divided by x minus L the whole square minus 1 divided by x plus L the whole square. Will continue. Okay, we can put LCM and we have to simplify. KQ into how much will come? We'll open a bracket. This minus this one. So x plus L the whole square minus this will go to this side, and x minus L the whole square whole divided by x plus L the whole square into x minus L the whole square. Okay, we have to simplify this. So KQ into x square L square will be here in the numerator also. We'll simplify. So x square plus L square plus 2xl, a plus b the whole square, minus I'm multiplying. So minus x square minus L square. What will come? A minus b. So minus 2ab. So this become plus 2xl whole divided by a plus b into a minus b. A square minus b square. So which means x square minus L square. A plus b into a minus b. And we have one more square because of this one. So this is a steps will be here. We are continuing on this sides, the further steps. Okay. So we are here. So what are the terms will get cancelled? X square cancel, x square cancels. L square cancel, L square cancels. 2xl will be there on the numerator. So k into 2xl and 2xl. So totally it is 4xl whole divided by x square minus L square whole square. Okay. Here we are going to do certain assumptions. We know comparable to x. The definition of dipole states that two equal and opposite charges separated by a shorter distance. So 2L is shorter, L is again half. So again it's very small. So here I can say x is much greater than L. In this case L can be neglected. L can be neglected because comparable to this L is a very less value and we are taking the square of that value means again very less. So L can be neglected. So how we can do? KQ into 4XL. Do not eliminate from numerator. When square will comes only it is less, otherwise it's not less. So here I can neglect L square. L is small, so square is small. You can consider, for example, L will be equal to 1 by 4, 0.25. If you are taking L square, how much will come? 1 by 16, very small. This is 0.25, right? This is how much will come? 0.1 by 16 means within 10, within 100, 0.0 something. So it is further very less. So if it is further very less means 0. How much will come? 1 divided by 16, 1 by 4, again 0.2. So okay, this 1 by 16, this can be written as 0.25 divided by 4. Correct, 0.25 divided by 4. So which means this is again divided by 4. So that 4 times this quantity will be lesser. 4 times quantity will be lesser will come only if you are taking the square value. So for the numerator there is no square, so we are not neglecting. Only at the denominator we are neglecting. So x square minus L square. So here x square, L square neglected, one more square. So here x power 4 x will be there in the numerator. So these terms can be neglected. KQ into 4 times of x cancel, L divided by x cube will be there. Here what is Q into 2L? We know Q into 2L is called, what is called? Dipole moment. We know, we are substituting this stuffs will be here. So we know this value. Now we are substituting. So what is coming? 2 into Kp divided by x cube. This is the direction of and the magnitude of electric field intensity. So if you look, will be here, you know K is a constant, X is a distance vector, P is an electric dipole moment. So electric dipole moment is a vector quantity, electric field is also in the vector quantity. The direction of electric field intensity is decided by the direction of dipole moment, which means in this case our final electric field is in this direction. Dipole moment is also in the direction. Okay, so the direction of dipole moment and the direction of electric field intensity. The direction of dipole moment is this one. The direction of electric field intensity is this one. Both are in the same direction. So here this is a magnitude value and we can write a note, write down on your notebook a note. A note means an additional point. In this case, this special cases, that means electric field is along the axis of a dipole. In this case, the angle between electric dipole moment P and electric field, what is the value? What's the value? This is the direction of P and this is the direction of electric field. Both are parallel. Parallel means what is the angle between them? Is equal to 0 degree. Important entrance question. What is the angle between electric field intensity and that of dipole moment when we are calculating the electric field intensity along the axis of a dipole? This equation is important, this note is important. 2 points are important. So electric field intensity along the axis of a dipole, the final electric field direction is same as the direction of electric dipole moment. As I told before, the direction of electric dipole moment is always from minus q to plus q. So that is clear. So hence angle will be equal to 0 and the formula is 2 kp divided by x cube. K, of course you know, 1 by 4 pi epsilon 0, 9 into 10 power 9. Okay. So remember this formula. This is electric field along this axis.